Welcome to the deep dive. Today, we are tackling something huge. Planet-sized, really.
Yeah.
The extinction crisis. It's gotten so bad, the UN now estimates over 1 million species are threatened with extinction. That number is... No, it's hard to wrap your head around.
It really is. And the scale of the change, habitat loss, climate shifts, it means that our traditional conservation methods, while they're still vital, boots on the ground stuff, they just can't keep pace anymore. The problem's accelerating way faster than our ability to even monitor it properly.
Yeah, and the weird thing is conservationists are now almost drowning in data. There's this constant stream, 247 from everywhere. Remote camera traps, fancy ocean sensors, satellites snapping pictures, GPS collars on animals.
The sheer volume is paralyzing, honestly. Trying to analyze that manually, going through image after image or hours and hours of audio, it's not just hard, it's basically impossible. Researchers are always playing catch-up, which leads to, policies based on old news.
Right. So today, our deep dive is all about this digital revolution in wildlife conservation. We want to get under the hood, understand how artificial intelligence AI is becoming this crucial tool, how it's turning that data overload into something useful, something actionable in real time. And importantly, what are the kind of unexpected side effects, the trade-offs of going so digital?
And when we talk about AI here, we need to be clear. It's not, Hollywood robots. We're talking about specialized machine learning systems, things like digital neural networks, computer vision. They're trained specifically for these conservation tasks. They learn to spot patterns and data visual patterns, sounds, numbers at speeds humans just can't match.
Yeah, and that must be the absolute game changer, right?
Yeah.
It speeds up the research massively, gives insights you maybe couldn't even see before using the old ways. So they're building a necessary management tool for the whole planet.
And it's definitely happening. You see these key players building the whole digital infrastructure, like AI2's Earth Ranger platform. That's a big one. It's more than just a database. It's like an integration hub, sort of the central nervous system for protected areas.
Okay, so tell us more about Earth Ranger. Lots of places have databases. What makes this so foundational?
Well, what's really clever about it is how it pulls together all these different kinds of data. Earth Ranger takes information from over 100 sources. Ranger reports, satellite tracking, camera trap photos, security alerts, everything. And it gives park managers this single, unified, real-time view. So instead of juggling 6 different systems to figure out what's happening with poaching or the weather or where the animals are, they see it all at once. It's already running in, 76 countries, supporting 650 protected areas.
That real-time view across agencies,
Mm-hmm.
that must completely change how quickly they can react. And then there are these global efforts focused just on making data available, like the Wildlife Insights Project.
Yeah, Wildlife Insights is also really key. They handle these enormous streams of camera trap data. But crucially, they make their AI models available for free to anyone in conservation. So this whole ecosystem, it's not locked down. It's built for collaboration, making sure even groups with smaller budgets can use these really advanced analysis tools.
Okay, let's dig into the core problem AI is solving here. This shift in the bottleneck. For years and years, the big challenge was just getting the data, wasn't it? It was expensive, difficult, logistically.
Oh, absolutely. Hard to collect. But then technology changed fast, sensors got cheaper, GPS trackers became common, digital storage exploded, and almost overnight, the problem flipped. It went from collection being the hard part to processing it. As some researchers put it, we went from struggling to get data to just, drowning in data. Making sense of that massive nonstop flow that became the new challenge.
And this is where the sheer processing speed of AI just offers this incredible value. That story about Idaho Fish and Game really hits this home, the problem with the time lag. They were getting, 2 million camera trap images a year?
Exactly. And that explains why conservation decisions were often so slow, so reactive. Before they brought in AI, humans had to painstakingly sort through all those 2 million pictures. Just doing the analysis to figure out population numbers took so long that by the time the state set hunting quotas or decided where to put resources, the data they were using was maybe 5 years old? You're essentially trying to manage today's crisis using yesterday's information, maybe even last decade's.
Which is just not good enough when things change so quickly on the ground. So how did AI speed that up for them?
The difference was, it was dramatic. They brought in computer vision trained to spot the animals, classify them automatically, filter out all the empty pictures of just grass waving. And now, Using these AI systems, a small team, just 4 analysts, can get through 18 million images, 9 times the old volume collected over a year, in just a few weeks. This lets Fish and Game make informed decisions, adapt their management plans, all within the same year the data came in.
That speed isn't just about convenience, is it? It actually changes the whole structure of how policy gets made. That feels like the biggest shift AI brings. But maybe break it down for us. On a practical level, what is AI actually doing in conservation? We probably group it into maybe 4 main jobs. Let's start with the most obvious one, monitoring wildlife.
Right. Monitoring is kind of the bread and butter. This is where you have AI-powered cameras, drones, fixed sensors, using computer vision to track animals, count them, identify species, or even just flag weird activity, like wildlife protection solutions. They process something like 65,000 photos a day from their cameras. The AI gives them real-time alerts if, say, a high-value species pops up near a known danger zone.
Okay, so that's watching what's happening now. The second function moves more into prediction, right? Predictive analytics, trying to get ahead of problems.
This is where it gets really powerful, I think. AI chews through these huge, messy data sets, satellite images, old weather records, land use maps, human population data, all sorts of things. And it builds these complex forecast models. They predict outcomes like where are invasive species likely to show up next? Or how will climate change, like a big drought, affect where animals can live? Which migration routes are most threatened by roads or development? This lets managers be proactive, put resources where they're going to be needed, not just where they were needed last year.
Third is that big category, data analysis and insights. Sounds straightforward, but it's about the AI spotting patterns humans might miss.
Exactly. These algorithms can sift through millions of data points at once and find these really subtle but important patterns. Like maybe they identify corridors between habitats that nobody realized were so important for multiple species. Or they can help optimize the layout of a protected area based on where animals actually spend their time, making sure limited resources go exactly where they'll do the most good.
And the last one is behavioral analysis. Understanding why animals do what they do seems key, especially for managing that tricky human-wildlife conflict.
Oh, definitely. That's a huge area of focus now. AI2's Earth Ranger platform, for example, uses its massive database of elephant movements, one of the biggest in the world, actually, and they're building predictive models specifically for elephant behavior. By understanding their foraging habits, their movement patterns, the AI can sort of anticipate when a herd might wander close to farms or villages. Managers get real-time alerts so they can try to safely guide the elephants away before they raid crops, preventing conflict and, potential retaliation against the animals.
That ability to get ahead of conflict, that's massive.
Yeah.
But these systems, they only work if the images they get are good. Let's pivot now to how AI sees the world visual identification. So when AI looks at these pictures, the really cutting-edge stuff isn't just saying, oh, that's a jaguar. It's figuring out which specific jaguar it is.
That's the truly transformative part. A biologist, Nathaniel Hitt at USGS, really emphasized this. Moving from just species ID to individual ID is fundamental for proper quantitative conservation. If you want to know if a population is really growing or shrinking, you absolutely have to avoid counting the same animal twice. You need tech that works kind of like facial recognition for humans, but for, animal stripes or spots or fins.
And the story of how this individual recognition tech started, now mostly driven by WildMe, it's pretty cool. It starts with a diver, Jason Holmberg, off Africa back in 2002, watching whale sharks.
Yeah, Holmberg had this realization the answer was literally written on the shark's skin. Well, whale sharks have these unique patterns of spots, completely individual. So we thought, why are we still using these invasive tags that can stress the animal out when their natural markings are basically a built-in unique fingerprint? That was a real light bulb moment. The animal carries its own ID.
So he figured out how to teach computers to tell those patterns apart, which led to the WildMe platform. It's open source now under Conservation X Labs. And whale sharks, by the way, they're endangered now.
No, they're
Important indicators too, right? Because they need tons of plankton, so they tell us a lot about ocean health.
And the scale WildMe operates at now is just incredible. Their platform hosts projects tracking almost 200,000 individual animals across 53 species. You've got famous ones like Manta Matcher for manta rays, Giraffe Spotter. The key is that the data comes from everywhere. Citizen scientists, researchers, they've got 14 million photos contributed from all over the world.
And that crowdsourced data gives real, immediate insights for policy. Like that example of tracking one single whale shark using photos submitted by different people.
Exactly. They tracked this one individual shark traveling between Mexico, Belize, Honduras, the US, and Cuba. That data proved fundamentally that conservation efforts couldn't just stop at national borders. Protecting those migration routes needs countries working together. That insight came directly from AI processing millions of photos, confirming it was the same fish crossing all those lines repeatedly.
Wow. And that idea, non-invasive individual ID, it works for much smaller animals too. Connects us to those canaries in the coal mine.
Yeah.
Which brings us to the Trout Spotter Project.
Yeah, brook trout, they're a classic climate indicator species. Super sensitive. They need cold water, consistently below 68 Fahrenheit, 20 Celsius, just to survive and breed. Trying to monitor them across their huge range, Appalachia up to the Great Lakes. It's just too big a job for any one agency.
So how does the AI identify one specific little fish that moves so fast?
Well, some clever grad students develop these algorithms trained to read the unique parr markings on the fish's skin. Parr marks, for anyone listening, are those sort of vertical bars or blotches you see on young trout and salmon. They're like camouflage, kind of like fish freckles, but they're unique to each individual fish while they're young, like a temporary fingerprint.
That's amazing pattern recognition. But how do they get the photos into the system?
That's the really smart part, the crowdsourcing. USGS partnered with Trout Unlimited, the angling group. They have this app, it's in beta, where anglers, who are basically citizen scientists here, just upload photos of the trout they catch. The AI scans the database, looks for a match. If it finds one, boom. It emails the angler the fish's history, when and where it was caught before, how big it was. It creates this really cool personal connection for the angler, makes them feel part of the science. And at the same time, it builds this unprecedented, detailed picture of population health for the scientists.
Okay, so zooming out again to the really big picture. The global camera trap network. That's maybe the most visible use of AI power. You mentioned Wildlife Insights, the WWF Google collab, and their SpeciesNet model.
SpeciesNet is a serious beast, computationally speaking. It was trained on over 65 million images that conservationists from all over the world chipped in. And its performance is really impressive. It correctly spots 99.4% of images that actually have an animal in them. And when it guesses the species, it gets it right 94.5% of the time.
That 94.5% accuracy number, that sounds crucial. Why is that specific level of accuracy so important?
Well, think about the economics of conservation. It completely changes the budget. Instead of paying someone, say, $30,000 a year to sit there and manually click through a million photos, 94.5% of that tedious work gets done instantly and correctly by the AI. That frees up precious money and a precious human time for the conservation group to actually do stuff on the ground, habitat work, community programs, anti-poaching patrols, rather than just sorting data.
Right, it's basically an optimization tool for groups that are always short on resources.
Yeah.
And we see this actually working in places like Peru's Talamano region.
Absolutely. Down there, they used SpeciesNet to process images from 136 camera traps. It helped them confirm they had 37 individual jaguars, healthy populations, plus tapirs, peccaries. But they also used it to check if their own conservation projects were working.
You mean like auditing their own interventions?
Exactly. They'd built these canopy bridges over roads, hoping tree-dwelling animals would use them to cross safely. Using the data processed by SpeciesNet, they confirmed that 6 key species, 5 kinds of primates, and the kinkajou were regularly using the bridges. That's immediate quantitative proof that their investment was actually helping the animals.
Okay, so if the last bit was about what AI sees, this next part is about what it hears. Let's shift from the visual world of spots and stripes to acoustic monitoring. AI listening to the world.
Yeah, moving from sight to sound is really important because audio data is often continuous, and you can collect it without disturbing anything. The history here in the ocean is pretty wild. Back in the 50s, U.S. Navy guys listening for Russian submarines on their hydrophones started noticing humpback whales were singing these incredibly complex songs.
And they kept it secret for ages, right?
Right.
Partly worried fishermen would use the tech to hunt the whales, which were already in big trouble.
Right. Now, fast forward to today, you've got someone like Ann Allen, an NOAA oceanographer, who basically inherited this massive headache. Almost 170,000 hours of recorded underwater sound, collected over more than 10 years, a huge archive of noise.
Just an impossible amount for humans to analyze traditionally.
Totally. But she collaborated with Google's AI team, and they used machine learning to chew through that data much faster. The AI learned to pick out specific whale sounds, pinpointing exactly when and where they occurred. That revealed patterns in seasonal movements, changes in singing behavior, and maybe most importantly, shifts in where the whales were hanging out. Knowing where they used to sing helps scientists understand if they're now moving away from areas with lots of ship noise or drilling activity.
And this acoustic monitoring isn't just for huge whales, right? On land, people are identifying individual wolves in Yellowstone by their unique howl signature.
Yeah, their acoustic fingerprint, the specific pitch, the rhythm, the sort of texture of their howls, growls, barks, it can be unique. And that ability to monitor the soundscape, it has immediate security uses too. Things like the Rainforest Connection Guardian devices, they aren't just listening for animals. They're trained to recognize the sound of illegal activity specifically, chainsaws or gunshots deep in remote forests.
And because these are network devices, solar-powered, they can send real-time alerts to rangers on the ground. Which brings us right into anti-poaching and security. The most endangered animals often need the most high-tech protection, it seems.
Definitely. Look at rhinos, only about 28,000 left. Protecting them is tough. They roam over huge areas. So this company, Ruxel Technology, developed rhino watches. They're these small, tough collars deployed on over 1,200 rhinos now, mainly in South Africa.
How does a watch act like a bodyguard for a rhino?
Well, the watch constantly tracks the rhino's movement, even some physiological stuff. The AI learns the rhino's normal routine, grazing here, resting there, going to the water hole. Then it flags anything abnormal that could signal danger. A sudden sprint, wandering way outside its usual area, or movements that suggest fighting. Or crucially, interaction with humans, poachers. This system feeds into Earth Ranger, giving rangers that immediate, potentially life-saving heads up.
That's reacting to a threat, which is vital. But conservationists are also trying to get ahead of the game using predictive defense.
Exactly. Using machine learning to guess where poaching might happen before it does. There are a couple of key software tools here. Pause AI and Smart software. Pause is protection assistant for wildlife security, and Smart is the spatial monitoring and reporting tool.
Can you quickly explain how they work together? What's the difference?
So Smart is often the foundation. It's where rangers log all their patrol data, where they went, where they found snares, signs of illegal entry, that kind of thing. Then Pause AI takes all that historical Smart data and crunches it. It looks at things like weather, the phase of the moon, time of day, where animals are known to be, and it builds these sophisticated risk maps. It doesn't just show where poaching happened, it predicts where the next attack is most likely. This lets managers plan ranger patrols much more strategically, focusing their limited resources on the absolute highest risk zones. It makes patrols way more effective.
Okay, so from protecting individuals on the ground, we go way up high. Satellites. I heard AI is actually running on the satellites now, not just analyzing data back on Earth.
That speed is critical, especially for things like wildfires that spread incredibly fast. There's a company, Aurora Tech, monitoring over 30 million hectares. That's almost the size of Germany for fire detection. They actually fly an NVIDIA processing unit, like a powerful graphics card, on board their satellites.
Why process the data up there? Why not just beam it down?
It's all about speed. The time lag between spotting a fire and getting the alert to firefighters can be the difference between containing it and having a catastrophe. By processing the satellite images right there in orbit, they cut the delay way down. They can get fire alerts out sometimes just 5 minutes after the satellite takes the picture. That immediate warning is huge for crews trying to respond quickly, especially in remote areas.
And we're seeing similar things for marine habitats, using satellite data for things you can't easily see, like coral reef health.
Yep. Down in the Caribbean, groups like Caricos use AI to analyze satellite data for real-time ocean conditions, temperature, cloud cover, currents. This is super important for monitoring coral reefs in marine protected areas. Corals are really sensitive, especially to temperature changes. This rapid analysis helps managers get early warnings about potential bleaching events, or maybe spot illegal fishing activity that might be hidden by clouds or murky water.
Okay, this is where it gets really cool, I think. The way this super complex AI meets, well, just regular people with smartphones, the sheer amount of data collected by the public seems to be fueling a lot of these breakthroughs.
Oh, the citizen science engine is absolutely crucial. You take platforms like iNaturalist, people call it iNat. Anyone can just snap a photo of a plant or animal, upload it, and contribute to this massive global biodiversity survey. The iNat library has, what, 500 million images now? And it's growing constantly.
500 million. And this data, even though it's maybe a bit messy, it's given to scientists for free and used in thousands of studies. It basically turns anyone who's curious into a field assistant.
And it's not just, cataloging stuff we already know. People using iNat have actually rediscovered species thought to be extinct. And they're helping find brand new species pretty regularly, about one a month on average. There was that great story of the praying mantis in Australia, first spotted by an iNet user, and they named it Anemia after the platform.
That's brilliant. But how do you make sure the data from the public, who aren't necessarily trained experts, is actually reliable enough for the AI to learn from?
That's where platforms like Zooniverse come in. They often use this really clever gamified approach. They show the same image or data point to multiple non-experts. By getting agreement from several people, yes, that's a bird, no, that's just a leaf, they validate the data and use that consensus to train the AI more accurately. It's called a human-in-the-loop system. It combines public enthusiasm with a way to ensure quality control.
But the thing that really seems to be turbocharging this whole field is open access. We talked about SpeciesNet earlier. Why is making powerful AI models like that open source so important?
It's huge. It's the difference between slow, walled-off progress and rapid global innovation. Open source means developers and conservationists anywhere can grab the code, use it, tweak it, improve it, and share those improvements back. The model gets better, faster. And critically, it means that free, high-quality platforms like Wildbook AI, which uses WildMe's tech, and Zooniverse are available to smaller NGOs, research groups in developing countries, organizations that just could never afford the massive price tags of proprietary software. It really levels the playing field, democratizes the tools.
Let's talk about one group that really leans into this mix of tech and community, WildTrack. Their whole focus is on something really low-tech, footprints.
WildTrek is fascinating because their mission explicitly combines AI, data analytics, and traditional ecological knowledge tech. Their whole approach is non-invasive. They've developed AI models that can look at just a simple photo of an animal track in the mud or sand and identify the species, the specific individual, its sex, even its age class.
Okay, let's clarify that term, traditional ecological knowledge. Two-way, what does that mean in this context?
Yeah. So tech is basically the deep knowledge that indigenous and local communities build up over generations about their environment, how animals behave, how ecosystems work, passed down through experience and storytelling. For WildTrack, it means they don't just rely on the AI. They partner with local trackers, people who have been reading those footprints, understanding that landscape for centuries.
So the AI isn't replacing the human expert, it's working with them. The local wisdom guides the AI.
Precisely. The trackers know where to look, what subtle signs mean. They provide the context. The AI provides the scale and the processing power to analyze thousands of footprints. They've got algorithms for 41 species now, showing that you can do serious science using these non-invasive, community-first methods.
Okay, so we've spent a lot of time talking about the amazing potential that power AI brings. But, whenever you introduce technology this powerful, you absolutely have to talk about the risks, the ethics. We need that watchdog perspective.
And Nicholas Millet from the Future Society offers a really important caution here. He warns against what he calls techno-solutionism. That's the trap of thinking AI must be the answer just because it's new and powerful. He argues we always need to ask, is it actually necessary here? Is it genuinely useful? Or are we just adding tech for tech's sake?
And a fundamental issue with AI, always, is the bias problem, isn't it? The models are only as smart or as fair as the data they learn from.
This is a really deep challenge. If most of the data used to train these conservation AIs comes from, say, well-funded projects in North America or Europe, the global north, then the AI's understanding of the world, its predictions, will inevitably reflect that bias. It risks sidelining species or ecosystems in the global south, or worse, dismissing local knowledge, like tech, simply because it wasn't in the initial training data. If the AI hasn't seen it, it might assume it's not important.
That systemic bias is a major risk. Then there's the more sort of human cost, the concern about the extinction of experience, the idea that relying too much on data models might actually stifle scientific creativity and discovery.
Yeah, this is a really compelling point raised by Denver Holt. He's an owl biologist who spent decades in the field. He says, look, tech is great for efficiency, but actually being out there, observing, that's where new ideas come from. Unexpected questions pop up. His worry is pretty stark, that we'll end up with people building complex models of habitats who've never actually seen the animal they're modeling in its natural environment.
You mean they understand the data patterns on the screen, but they lack that gut feeling, that intuition that comes from direct experience.
Exactly. Holt literally said, I know people who are modeling owls and owl habitat who have never seen an owl. If the data model becomes the only source of truth, instead of just one tool alongside fieldwork, we could lose that deep qualitative understanding that experienced researchers bring. It's about balancing the quantitative speed with that qualitative wisdom.
That balance, AI speed versus human experience, seems critical. And finally, we can't ignore the basic security and privacy issues that come with plastering sensors everywhere.
Absolutely. There's the danger of the AI just getting it wrong, misinterpreting something harmless as a threat, leading to wasted resources or worse. But maybe even more worrying, what if sophisticated poachers could somehow hack into or exploit these systems? If an open platform accidentally reveals precise, real-time locations of endangered animals, that could be catastrophic. The stakes are incredibly high.
So you need safeguards. You need to monitor the monitors, make sure the tech is serving conservation, not enabling crime.
And that oversight has to include human rights, too. Mial really stresses this point. We need to ensure that all these cameras and listening devices deployed to catch poachers don't end up violating the privacy of the local people who live nearby. There have to be rules and safeguards. The bottom line has to be that the technology serves conservation and the communities involved, not the other way around. #tag outro.
So putting it all together, what's this mean for tackling that massive extinction crisis? We've gone from AI reading unique spots on a whale shark to processing 18 million photos in weeks to listening for chainsaws deep in a forest. It's an incredible range of tools.
I think the main takeaway is pretty clear. AI is becoming indispensable simply because of the scale and speed of the problem, the amount of data, the pace of environmental change. We need these tools. It lets conservation shift, from just reacting to things that have already happened to being more proactive, more predictive, trying to get ahead of threats, saving crucial time and money.
And while there are definitely risks, the cost, the potential for bias, that tension with traditional fieldwork, it feels like without this tech, the fight to save those million threatened species would be significantly harder, maybe even impossible in some cases.
Which leads to maybe a final thought for you, the listener, to ponder. We have AI that can track an animal's every move, recognize its voice, file it away in a database of billions of images. But does focusing so much computing power on cataloging life risk us valuing the data more than the direct human connection often needed to inspire action to save it? What's the right balance between the algorithm telling us where the rhinos are and the experience tracker's anecdote that tells us why they go there? Maybe explore that balance yourself. Try downloading a citizen science app like iNaturalist. See what you discover. Contribute your own piece to the puzzle.
Thank you for diving deep with us today. We'll catch you next time.